This meeting is being recorded.
So, hello and welcome everyone. By the way, please turn off your microphone as long as you don't try to speak. So, but if you would like to speak, then okay, go ahead and turn on the microphone. So, welcome to this workshop meeting, and whoever watches the video, welcome to the video. My name is Gabor Sabo. In this probably about an hour, I'll try to give you a little introduction to Docker and something how to use it with Perl. Sort of, I assume that you don't know Docker, but on the other hand, I won't go in very much details because 1 hour is not really enough for that. We'll try to have a few examples using Docker. About myself, I just noticed that I started to program more than 40 years ago. And I've been writing Perl since about 95-ish, sort of. I think I started, maybe a little bit later. And I was teaching Perl for many years. I participated in quite a few things regarding Perl. Unfortunately, in the recent years, there's not much Perl training going on. Well, at least definitely not for me. I still run the Perl Weekly, as you might know, the Perl Weekly newsletter. I used to write this, used to have this IDE called Padre, which was the Perl IDE. Unfortunately, that also stopped being developed basically because there wasn't enough interest. So as a job or as an income, I mostly teach people at companies. As I said, I used to teach mostly Perl, and then quite a few years I taught Python as well. And these days I also start teaching Rust language, these programming languages. And along these languages, I teach quite a few things about Git and GitHub, things like continuous integration. One of my favorite topics was in every language is basically writing tests and making sure that our code actually does what we want to do. And then that follows that I help people and companies how to set up continuous integration. So I help introducing test automation into the companies. It used to be for quite a while Jenkins, and nowadays when companies use GitHub, then they're GitHub Actions, and we're going to have a separate meeting about that, which is actually has a it makes quite a lot of use in Docker. So it's a good thing to understand Docker before you start to do GitHub Actions, because there you can use quite a lot of things with Docker. And of course, with GitLab, if people are using their companies using GitLab, and they have their own continuous integration system or pipeline, and I teach that and help companies with that. Let me start sharing my screen, and hopefully I can show something. Actually, before I start sharing the screen, a couple of words about what problems Docker solves, okay, before we actually get started. So if you're using Perl, then you probably are used to, when you're writing a Perl project, then you need to somehow describe your dependencies. And Perl has a couple of ways to describe the dependencies of what kind of other Perl modules your code depend on. And the most ancient one of these, and probably the most used one, is having a makefile PL, and then in the makefile PL listing your dependencies. And in those files, you can say you are depending on some module, and you can also set the minimal version of it. Unfortunately, actually, let me show this already. I think I can share the screen, and I can show built-in display. Hopefully, you can see now. Okay. Hopefully, it will work out also. So these are just some notes that I put together for myself. It's on on one of the websites and some links about this meeting. So I'm quite sure that if I go, let me just open a different, oops, with the window. So in this small project I started to put together so I can show you something with Docker. I have this makefile PL, and in this makefile I have the dependency, in this case dbdpg, which is the Postgres client. And personally here I set the minimum version to 0. It also required a test more. You can have a long list of it. Now this is nice, and it can ensure that your project has the minimal version, but a couple of problems. First of all, this only sets the minimum version, and not the exact version. You might be able to set the exact version, but this the way I do it is not. Besides that, many of the libraries that you use, many of the modules you use, will also have their own dependencies, and there we don't set the exact version we need. So if you have other computer where you would like to install exactly the same setup, the exactly same Perl modules, this probably not enough. But that's one of the first steps to make your environment recreatable. And this is the big problem, one of the big problems that Docker solves. So maybe the biggest problem is that how to ensure that the computer you're running on during production, before the production, you started to develop your project, there's another programmer comes in the company. How can you set up the environment of that person to be the same as yours? So they won't use a different version of Perl, a different version of the modules, and so on. And if you go further and you move the project to testing, then how can you make sure that in the testing environment you have the exact same things? And in production, how can you make sure that you have the exact same things there? And for Perl, as I said, you can start with setting up the makefile PL. And I encountered quite a few companies where I visited that they didn't even have that one. They just had like somewhere a list of the modules to be installed. But that doesn't cannot precisely say exactly what modules to install, which version of what modules to install, especially not the deeper dependencies. So if I depend on some module and that depends on some other module, I don't usually I won't fix the version, the exact version. Now for that to set, you have another library for Perl, another module, another tool called Carton. That can be, and here's the link, and I will put it on the website so you'll be able to access it. That can help with that. But even that, and in Carton, you actually define the exact, or somehow you basically define the exact version of every module that you depend on, even if you're not depending on directly, but it's in some hierarchy. But even that is still only helping you with the Perl dependencies. So not with anything else. And I'm just checking it because I usually forget to check it. There are 26 participants now. Very nice. And it's growing. Okay, the number of people is growing. Very nice. Anyway, sorry that I'm being enthusiastic about it. So the other dependencies are not described by neither by makefile PL nor by Carton. So for example, it doesn't say which operating system you are using, which version of that operating system you're using, what kind of maybe C libraries which version of the C libraries you're using. When, for example, you need to compile install dbd Postgres, that will compile itself with the Postgres header files. Which ones, okay? How can you ensure that these are the exact same version as you had on a different computer? And that's your software now, okay? But let's say somehow you manage to do that, and actually Docker helps you quite a lot, or does this for you. But in a project, you don't have only your Perl code with its dependencies, Perl and otherwise dependencies. You will always also use all kind of other external things like databases. So for example, you will have to access some PostgreSQL database or some Redis database or MongoDB or lots of other things. How can you make sure, first of all, how can you make sure that when some other person sets up on the new developer sets up the environment, that person will set up the exact same version of everything, and you have the same thing on in production as well? That's really hard. You will have to have a lot of documentation for that and so on. But it's also it takes a lot of time to set up. So I went to companies, I consulted with companies where in order to set up your environment, people were spending days to set up the environment. They usually don't really have good documentation for that. So it was a mess. Now with Docker and with an add-on tool, or actually nowadays it's part of Docker, which is called Docker Compose. Together with this, you can create configuration files that will describe exactly everything you need to install. Okay, the exact version of everything, and then so that will make it very easy to rebuild the whole thing, the exact version. But not only that, you can create using Docker. You can create what we call images, Docker images, where you have already installed everything you wanted, okay? And then you can pass on these images to other developers or the production or wherever. And if they use that image to run their environment, then they don't even really need to install anything, of course, beyond Docker. Or so you have to have Docker itself. Okay, so that's the main thing that Docker solves. Now, let me find an image that maybe you can describe it. Docker stack, maybe. What is I'm trying to show you an image that might help. Okay, this can help. Okay, explaining one of these things can help. So to explain what is this, how Docker really works. So assuming you have Linux, okay, you have the hardware, you have the your own Linux running on it, then there is something called the Docker engine that you have to. It's a daemon, it's a service on your computer, and then you have the Docker client, which is the Docker command actually that you will run. So we're going to run here commands like Docker. I just wrote run Docker. This is Docker client. This talks to the Docker engine, Docker server, and tells it to do all kind of things. Now, when you are developing, these two things are on the same computer, but you could actually put this on some remote computer, and then you can run the Docker client locally on your computer, let's say, and this whole thing is on some remote computer, and you talk to that one. Okay, so you could also have that one. There is something called the Docker desktop, and I'm not sure how to explain this. This is sort of a GUI especially for Windows, I think also for Mac, that allows you to execute things that you would do with the Docker client. You also, in Windows, you also probably will have to run the Docker desktop, and from the desktop you will have to tell it, okay, to run the engine, because in Windows, I think by default, and then you can configure there in the UI to always start the engine when you start your Windows machine, if you have Windows machine, obviously. With Linux, if you're running Linux, then this Docker engine is just a service that you can enable, disable as any other service on your computer. And then when you're running a Docker, and then we're talking about running Docker containers, they are sort of on top of this. So this is sort of explaining an advantage of Docker versus virtual, what is it called, virtual boxes and all kind of other virtualization systems. if on what is it called? I forgot it. Yeah, VirtualBox, right?
Virtual machines.
Yeah, virtual machines. Yeah, but it's not the same virtual machine like Java
Like
has.
like Vagrant or something like that.
No. It's you have the Oracle VirtualBox, which is now Oracle, but it used to be just an open source project. I'm showing you this one. If I can grab it, this one. Okay, are you familiar with it? In which you can install basically full operating system. So I'm running those on my computer, and you can't see it because the fonts are so small. This problem on my computer, but let me close it, please. Yeah, okay. VirtualBox. So this is one of the tools, okay, that allows you to run on your computer this VirtualBox, and then on top of this you can install whatever operating system you like. So you can install, well, it's usually Linux or Windows, but you can theoretically you could install all kind of other things as well. So this is one of the other ways of virtualization. The advantage of Docker over this is that if you need multiple, let's say you have different services that you want to run, your code, Postgres database, a MongoDB, and whatever something else, and you want to have the separation to make sure that it's similar to what will be the production environment. Then you have to run 4 Linux machines on top of your VirtualBox, which is a lot of resources. On the other hand, if you're using Docker, then all of these containers are running on the same Linux kernel that you have here, okay, on your computer. So they are basically running natively on your computer. They just don't have the rights to access all kind of things. Okay, so it uses a lot, the resources it uses a lot better than if you're using some other kind of these VirtualBox or some other kind of virtualization. I'm trying to find another drawing where you might be able to see the Windows version. Not exactly. Docker stack on Windows, because on Windows it's slightly different. Not exactly. I can't really. Oh, okay. Yeah. So okay, here's the drawing of showing what is the difference between virtual machines and the containers. So you have this extra layer here, the guest operating system everywhere, and here you don't really have that. So in Windows, I can't really find the drawing. On Windows, the problem is that the underlying operating system is not the same as you would like your guest to be. So you're running a Docker container, which is Linux-based something, and you're running Windows on your computer. So in order this to work, basically what Docker does, it runs a virtual box thingy, so like a VirtualBox, on top of your Windows. So now you have 2 operating systems, which is not that good as on Linux. But on top of this, okay, I was trying to show it with my hand, but I'm not sure if you can see it. On the top of this, it's running already these various containers. So it's not as efficient as if it would be if you were running on Linux natively, but still you only run 1 extra Linux and not 4. Okay, so that's an advantage. So that's a little bit of the background of how this Docker works. Now about words that people use, there is the image, which is like an ISO image. Think about it. So you have some kind of tools already packaged that you will need to be able to run your container. And we call it container when it's running. Okay, so basically a container is an instance of an image. You can think about that. So let's try to run something simple. I can, first of all, if I run Docker and I run image, ls, it will list all the images that are on my computer. Now it's empty because I just removed all the images, and so it's almost clear. And one of the most basic things that we can do is saying docker run, and you say hello. I think it's right, this hello world. Okay, and what does it do? It tries to find the image which is called hello world on my computer, but it can't find because I don't have any image there. So it says unable to find hello image latest locally. I talk about this latest later. So it tries to download the hello world from the central location of all the Docker images. It managed to download it. It tells me what is the here. I managed to download it. Fine, and then it runs the image. So converts it into a container and executes whatever is in the container. Now, in the container, you have just one command that you can run. This command can be really, really simple, like in this case. In this case, what the command does, it prints out this text message and then exits. So I just executed a container, a Docker container. I downloaded an image, ran a container, it printed out this screen, and that's it. It's gone. It stopped running. Okay. There are more interesting containers, obviously, where the program will run continuously, like a daemon, basically. And because it's running all the time, that's why the Docker container doesn't exit. It just keeps waiting. Okay. So now if I run Docker image again, the image ls, you can see that there is this image, which was this is the name of the image. The images have tags, which are basically like version numbers, and latest usually points to the latest one. But you can have version numbers, and then it has an ID. It says when was the image itself created, so it was more than a year ago, and what is the size of the image. If I run docker ps, that would list actually Docker container. There used to be these relatively short commands like docker ps, but a couple of years ago they started to make them more, let's say, correct. So you have now longer names. So and I will forget to use the longer names sometimes. Container, and here too I can run ls. Now it says it basically lists all the containers that are currently running, but none of them are running because the one that I ran already stopped. So I can provide the -a flag, and this one shows me all the containers. That's why -a, because all, including the ones that have stopped running. Okay, so this one stopped running 2 minutes ago, and as I'm going to run it again and run this again, it will tell me that it was 3 minutes ago, and so on. There's another thing here, which is the name of the container. Okay, it was randomly generated by Docker. I could provide the name of the container, but if I don't provide it, then it will randomly generate 2 words, and that's going to be the name of the container. The name must be unique, and it can be used to rerun the container or access the container, all kind of things. So it's a good thing that we have a name for it. We also have an ID at the left-hand side of the container, but well, that's not that user-friendly. So more user-friendly a name, and so if we could give it a name, and then it would be easier for us to remember. If I run Docker run hello world again, it will do almost the same, except, well, it doesn't talk about downloading it anymore, because now it looked for the container, the image locally, okay? And we saw that we have the image, we listed it here, so it's here. And so it just ran the container based on that image. And if I run Docker container ls -8, now you can see both of them, okay? What really happens, the image is just yeah.
I hate to interrupt you, but like your bottom command line is getting cut off because it's getting overlapped by the Zoom window. So if you could not use the bottom inch of the screen, that would be helpful.
Is it better now?
Totally, thank you.
Okay, you're welcome. Thanks for telling me. I keep forgetting this, that it happens. It's also then when they record it, when in the recording it's there, but when you watch it in YouTube, then it's again the bar is hiding it sometimes, so it's not that nice. Anyway, I should think about it. By the way, if you have any other questions as well, other comments, feel free just to comment. Okay, open it, and I need to open the chat window, which I forgot, and then maybe I can notice. Okay, so by the way, so someone commented here, Windows is only good for to run Linux. That's not the point that I wanted to comment on. I wanted to comment on that I haven't tried it, I think, but you can actually run Docker containers that are themselves Windows based. So if you need to, if your environment needs several Windows boxes for whatever reason, because that's what you need, then you can do that as well. I'm not sure if you can run it on Linux as well, but maybe you need the Windows machine for that. But I never tried that thing. So when we downloaded an image, okay, Docker downloaded the image, it takes up some disk space. In this case, not much, but some of the images can be quite large. And when you create a container, when you run, say Docker run, and you basically say Docker run the name of the image, but then we call it container because now it's a copy of the image that it's running, but that's a copy of the disk of the image, which again takes up space. And I guess there's some caching and then some optimizations, but these take up space, okay? And so you want to make sure that you don't keep around too many of these. And for that, you can do a couple of things. One of them is that you can, when I run Docker run, I could say --rm, and then what it will do create the container and run it. But if I list them, it's not there. Why? Because it automatically removed the container when it was done. In many cases, that's the right thing to do. Now, sometimes you do want to have the container around for some times, and then, like in this example I showed you, so I needed it. But then later on, you would like to remove it, so you can say Docker container rm and then name of the container or the ID, or you can say Docker container prune, and then it will ask you. I think you can have a flag, so it won't ask you, and then it will remove all the containers that are not running. So if there is a container that's actually running, it won't try to remove it. Okay, just the ones that were done already. Okay, so that's the basics of containers. Now, where did we get this image from? Let me try to find it. Yeah, I can open a new window. So there is this website called hub.docker.com, which is the central storage of all the Docker images. And then here you can find all kinds of images. For example, if you search for the word Perl, then you can find an image that already has Perl installed. Okay, I mean, the basic thing will be actually before that. Let's do before that. You can search for one which is called, let's say, Ubuntu. And then you can have an image which is a basic Ubuntu Docker image. And then you can say, okay, I would like to run this. And then you say Docker run, and you say Ubuntu. And here, if I don't say which version, it will pick up the latest, because that's the default. But I could actually here use the tags that are described on this website that are available. So I can say just Docker run Ubuntu, and it will use the latest Ubuntu that's available on that website, or I can say I want to use the, let's say, 2204, okay? And this is the tag, okay? And there are tons of other tags that you can play around with if you would like to specify which image to use. So I can say docker run, and now it can't find this image. It will download the image, and then it's downloaded. It doesn't need much, okay? It doesn't have all the other extra things because it just imitates Docker. Now I ran this image, but it didn't do anything because it's just an empty image without any command in it. What I might want to do here is say that I would like to run it I think I have to put it here, minus IT would means that means interactive. And I need a I think I need to give it a no, I don't. Okay, so I just told it to run it interactively. So now it started the container, and I am now inside that container. So I can run commands here, ls, ll, for example. Oh, it exists, for whatever. Okay, but we are inside a container, and we are user root inside a container. Okay, so now you can do anything you like, and we are inside a container. But let me see. Oops. What did I do? No, I didn't want to do this one. And enlarge. Oh, because the font size is different in the two windows. It's now doing this not really nice. Okay, let me try to fix this. But you don't want me to have it full screen. Okay. Sorry for this. Okay, now I can move between the two. Okay, fine. So in this window, in this terminal, you can see that I am inside the Docker container. Now I go to another terminal and I run docker ps, just ps. It will tell me it will talk about the container that's currently running. So this is the container that's running. If I run it with -a, then I will also see the other container, the other Ubuntu container that I ran a couple of minutes ago, 2 minutes ago, it says, where I didn't do that, we didn't provide it anything. Okay, and I can do that. I can see that I could remove this. Actually, if I docker container prune, okay, and it says, okay, remove everything, it will remove only one, right? Because the inspiring Mac CleanTalk or whatever it is, it's still running, so it doesn't, the prune doesn't remove it. Okay, so at this point, I could do whatever I would like with this container, play with it, install stuff in it, and then shut it down. And then once I shut it down, I could restart the container and get back whatever I did there. So that would be one way to use just the plain Linux. And let me start it again. Does it have Perl? It has Perl in it, okay? So because Ubuntu comes with Perl. So it has an old version of Perl. That's fine. You can now install other things and so on. But similar to this plain Ubuntu, there are many other images already on this website. And that's where comes, before I get to Perl, let's say I go to...
Sorry, may I ask a question?
Yeah, sure, go ahead.
If I understood it correctly, when entering the docker run command, you got into the container as root, right?
When you're entering the docker run command, and sorry, what?
You got into the Ubuntu container as
Yes,
root user.
because okay.
And when you entered it again, it started a second container, right?
Yes.
Is there a way to enter an already running container?
Yes, you can docker exec, and I always forget the command, so I have to look it up. but you can run docker exec and the name of the let me try to do this. Okay, actually, so docker. Let me try to do this. Okay, docker run here. Now this one, if I run ls here, these are the files here. So I'm going to create a file here. Touch Gabor was here. Okay, so now if I run ls, there is this file called Gabor was here inside the container. Okay, I'll exit, fine. Now if I run it again and ls, that file Gabor was here is not there because it's a different container. So it's copied the disk of the image and it's a different container. Now I just need to find which one was which one. Okay, so this one, I guess, was the one where I added the Gabor, this crazy thing. So I think I can run the following thing: docker exec name. I think no, I have to find it in my slides, maybe code Maven slides.
I
Yeah.
think you need -it.
Yeah, but I dash IT here too.
You can just docker exec the hash number.
So, wait a second. Let me. Rerun, restart, stop instance. Okay, I have it here. Okay, so this Docker container start. Sorry. Okay, I go always exec would be, I think, executing some code in there. So it's Docker container start -i and name of the container. Let's see if my slides is still up to date. Okay, right. Okay, so here it is, and Gabor was here is this one. Okay.
Thank you very much.
Okay, so this is how you can stop, and this is a very actually. Thank you for asking because I keep forgetting that this is one of the most important things to show. So I'll put it here somewhere, and I'm going to edit this file later on to have it with the presentation. Okay, so and again, oh yeah, I know, because the other window is not the same size. It changed this. Okay, so right. So one thing you can do is really start a Docker container, install all kind of stuff in it, and then you can stop it, and then you can start it again, and stop it and start it again, and keep working with it. And then you could actually take that container and convert it into an image and distribute it. And somewhere in my slides, I have a command for it, but it's not really good because then you don't really know how you actually created it. You don't have a specification how to install it. You just install stuff and it works, and then you say, okay, let's freeze it and give it to people. But you won't be able to recreate that same image with, let's say, the next version of all kind of things. So instead of that, a much better approach is to create a description of what you would like to have in your program. And before I show you, let me just get back to the thing that I wanted to show, the Perl. Actually, what I wanted here is, what is this called? WordPress. Okay, so just to show you the other end of it. So the one end would be to install a container, an image, which is Ubuntu, let's say, or one of the operating systems, which is a low-level image. The other end would be to install to use an image that is actually a full application already. So, for example, WordPress, it contains the website and probably a database and whatnot. So you will be able to, by installing this and running this, you will be able to run the WordPress web application. Okay, and that's it. And with the same way, you could set up, you can create and upload here as well other images, but there are tons of them here anyway. Some people commenting, every run will start a new, yeah. Okay. Yeah, someone want to that?
What if I want to create my own image?
So yeah, what I mentioned earlier, that you can create your own image by running the container, installing stuff in it, and then freezing it as an image. Not the right idea. We are going to create our own image in a second, okay? But now I'm sort of going to the middle ground where I'm going to pick up a Docker container, sorry, a Docker image with a very specific Perl version, okay? So for example, 540, okay? So I could run this, I could say Docker run, and I could say Perl and say 540, and that would run that down. It will download that image and run that container, and apparently it gets into the debugger. Okay. I can. Oh no! It exited from the debugger. Oh no! This is now font size. Okay. And here this one. Yeah, it will get better by the end of the video. Okay, so that way I could have run the Perl image, container, whatever, Docker container. Oh, actually, I have it here. Docker. You noticed? You didn't notice that I ran Docker PS and it's worked. That's the old command. So the right command would be Docker container PS -a. Both work, but this is sort of the future. I don't know if they're going to remove the old one. And I can get rid of them or now gone there, or I don't need to get rid of them. So what I need in order to create an image is I can create a file called Docker file, and this is exactly how it's called, Docker file with a capital D. You could actually use any other name, but this is the default name. And in this Docker file, you can describe what you would like to have in your Docker image. So here I starting it with saying, okay, I'm basing my image on this image, on this public image. Okay, and by the way, so the hub.docker.com is where Docker has its images, but every major cloud provider has its own Docker registry. So the generic name of this thing, the Docker Hub, is the Docker registry, where you can upload. It's like CPAN, right? Just for Docker images. But every major cloud provider, so GCP, Amazon, AWS, Azure, and all the others, have their own Docker registries. And I guess if you're using GCP, so the Google Cloud, then you're going to use their Docker registry. Actually, the last time I checked, Docker registry was an open source project, so you could download it and even run it internally in your company, which means that you could one employee could create an image some way, okay, preferably using this Docker file, upload to this registry, and then all the other people could use the regular Docker commands to install this. They will only need to tell that which registry to use, because the default is the Docker, the central registry. So here we are creating a new image based on the Perl image. And this is really not probably what you will do. What you will probably do, let me try to do this. So let me comment this out. So this is, I'm saying, okay, I'm basing the image on Perl 540. then I would like to run. So here in this project, it's usually inside your project. In this project, I already have the makefile PL. So in order to install all the dependencies, I need the makefile PL inside the container. Okay. So I need to copy the makefile PL locally. Now this is a strange thing, but this copy will copy the makefile PL on my disk, on my external list, to the internal disk of the container. And let's try to run this. Now, Docker build my image. I think it's minus the mine image dot. Right. Okay. So I created a Docker file that describes what should be in that Docker image. This command built a new image based on that Docker file. If I run Docker image ls, then you will see that there is now an image called my image, which I just created. And what does it contain? Now let's run this. So Docker run minus it my image, and let's run let's run bash in it. If I run ls minus l, you will see the makefile PL inside. Okay, so when we run Docker build, basically we start a process in which Docker runs a new container, executes those commands that are in the Docker file, and at the end creates a new image from all the installations. Okay, so what can we do here? Let me see. For example, I could run these commands. Okay, so this command will be run when the image is being built. Not when you're running the image, it's when the image is being built. This command will run when the image is being built. Now we would like to install all this all the dependencies inside the image. So we still run and cpan m install deps dot. That should hopefully install all the dependencies. Let's see if it does. I think it won't do because I need something, but we'll figure it out. Not this one, sorry. Docker build. Okay, so it failed the installation. Let me make it easier for it. And the dependency should be something else, not dbdpg, because dbdpg will be a difficult thing to install. Can you what a module which is simple to install? Tiny pass or pass tiny? No, it's called pass tiny, right? Yes, it's called path tiny.
But
yes. Let me run this and then I try to answer the question. Yes. Okay, no, it didn't like it.
don't you need to install build essentials and other?
Yes, probably that's what I'm missing. You're right. So Docker file, I need to also install, and the things I'm installing here is because I wanted to showcase something, the Postgres, but apt-get install -y, and it's called build essentials, right?
I'm terrible at typing, but yeah.
Let's see if that's the one. First of all, I'm too many slashes here, and maybe that's the problem. Okay, so it's installing stuff. So now the building of the image works, and it didn't like unable to locate package build essentials. Okay, opt cache search build without an S. It's just build essential, I think. Okay, so now it's installing the whole thing again. Fine. Okay, it has some issues. So let's try to make some improvement here. I'm going to remove this one now and rebuild the whole thing. It's much faster now because the way Docker builds is that each of these commands is caching whatever it built so far. So in the earlier, when it failed in our last command, by that time it already built all the previous ones and cached them. So now that I don't have the last command, it's just done. Okay, and now I can run Docker run this one and try to Perl manually install this. So warning could not open. Okay, yeah, maybe I need to copy this lib example as well. Make. Okay, so you see it was complaining that it was missing the lib example. So let me do something else. Instead of copying makefile PL, I'll leave it here for now, but I'm going to copy everything. Okay. So let's sorry, now I have to rebuild first. Perl makefile PL. Okay, make inst. Okay, cpan m install deps dot. Okay, so now it's installing the dependence and it's done. And what if I try to cpan m dbd-pg? Will it work? So what I would do is first try manually to install everything, and as I'm making progress and as I find out all kind of other dependencies like non-Perl dependencies that I need to install, I would add all of them to the Docker file, and then once I figure out how to do this, then I would be able to run this build with a single command, and it would build everything. Okay, that would be the ideal. It's working on it. Nice. Okay, let me while it's trying to work, show you something else. I won't probably be able to really show this, but I have a couple of Okay, so something else I wanted to show you is the Docker Compose. So besides the Docker file, okay, so the Docker file allows me to describe how to build a new Docker image. That's fine. But what happens if my project needs, besides my code, okay, besides my code, it also needs, let's say, a Postgres database. And that's what I was trying to show you here. In that case, what we need is, what we can use is the Docker Compose system, which these days is already part of Docker. It used to be a separate installation. Now I think it's just part of Docker. So in here, for this to work, you can create a file called Docker Compose YAML, a YAML file, in which you are describing what kind of services you would like to run in your system. And in this specific example, what we have two services. One service, which I called the client, it is going to run my own code. Okay. The other service is going to run, which I called PGDB server. You can name it any way you want. It will be a Postgres database, and this one is sort of the easier. It depends on the Postgres latest image. You could also say here an exact specific version of the Postgres, but for the easier example, I just used the latest. Then you can set up all kind of environment variables. So the Postgres server needs to be configured. And this is how you're going to configure the Postgres server and tell it, okay, the default user is called username, and the default password is called secret, and there is a database called MyDB. Nice. Okay, and I'm going to talk about the volume in a bit. So this way you create a database, a Postgres database. And then when you start this whole system, basically Docker will start you 2 containers. One running a Postgres database, and the other one is running whatever is described here. Now, what do we describe here? We say build the image based on the based on the Docker file in the current folder. So you don't have to build the Docker file with this external command that we did now. Okay, it's done, by the way. Okay, you don't need to do that. You only need to have a Docker file that already describes how to build the image. The Docker Compose will build the image, and it will link to this to the server, which is called PGDB server, which is the same name as here. So running this Docker Compose will basically create 2 containers, run 2 containers, and the client will be able to access the server using this name. So you will have a name resolution for PGDB server accessing this server. Okay, and then a couple of more things here, and then basically this is what I have here. I have here that I run. I need to run some command in the client. If I don't run any command in the client, then the client will start and stop immediately. In order to have the client running, I need to do this. Okay, so let me try to show this example. But for this, I quit the Docker. Actually, I can use, okay, I already have everything there, so I can use this one. I don't need anything special. So I can run now Docker Compose. So before I run it, what do I have here? I have a Docker file that says use Perl 540, install these stuff, and copy these files. Okay, it doesn't say the installation because I don't want to spend now time on this anymore. Okay, I have this one. In addition, I have in the same folder, I have this file that describes 2 services. Okay, and now I can run Docker Compose up. This builds that image if it needs to be built. It downloads the Postgres database. It downloads the Postgres image because I don't have it locally, and starts both of them. Okay, so you can see here the PGDB server running, and basically you can see two of them running. If I switch to another window, I can say Docker PS, and you can see there are two containers running. One is called Docker Compose Perl Postgres. It has a long name here. This is basically the client, and another one is the server. Now I can use now this command, Docker Compose exec. Here comes the exec. Name client and what to run in there. So I use the word client here because in the Docker Compose file, I called it client. So I say Docker Compose exec client and run bash client and run bash in it. This way, now I got inside the running container, which I called client. If I already had my Perl code installed here, then I would be able to run all the Perl stuff. So I can look around actually, and I have the makefile PL and the lib and everything copied here. But what I would like, yes?
Can you take the question? Everything you're doing in there, you're doing as root. Is that normal in a Docker container, including the Perl modules?
So it's rather normal, but you could actually set, and I have somewhere, I don't remember exactly how, but I have an article showing how you can tell it, and I think that's the better way. Okay, so normal meaning many people use it. Okay, not the secure one. Okay, just when you're using the word normal. Okay, so many people use this, not really the secure way. You could configure it to map the internal whatever, to create a user internally and also map it to your own user. Okay, and that will have all kind of advantages. Let me try to find the article for you. CodeMaven archive, Docker. Yeah, use this one.
Yeah. It's usually been my experience that you know, when you're setting up a Docker container, Docker image, you know, most things are done by root to just get everything installed, and then when it comes time to, you know, set up the particular application that's running in there, all that is done with an application specific user. And then you just, I mean, the idea with the, you know, the containers that are running off the image is, you know, you just build them up and tear them down as you need them. So they're not going to be run. I mean, most Docker containers are only running one thing, and most things you don't run, and you know, but you're not often you know, going into them interactively except to figure out if something's going wrong.
Right, right. And I really want to emphasize the one that you mentioned here, that as opposed to a normal virtual box or a normal Linux machine where you have several services on the machine, a Docker container usually runs one service. So one Docker container will run your Postgres database, another one will run your other service, other database service, the third one will run your code. And that's the level of separation.
And another thing to keep in mind when you're running security in a container-based environment, these things are typically running in namespaces and C groups, and so that really provides a more powerful and convenient mechanism for encapsulation than the typical username traditional Unix security does. So all of this stuff is in a multi-layered model, and obviously you want to do your best at every layer, but you know, having the wrong user inside your container isn't the same thing as having the wrong user inside of a service that's running on a host or something like that, where it's more dangerous.
Okay, thank you. I'm far from being a security expert, but thank you for the input. So any more comments here before I show you the basically this probably the last part of this? So now we are here I'm inside the client container, okay, and I can run basically I'm running a Postgres command against that server, which is called PGDB server, and it worked for me earlier and it works now, so I'm really happy. Okay, so you can see now that from the client I can actually access I send this select statement to the server, and then it executed that, well, rather simple, but still an SQL statement on that server, which is in the other container. And if I had time, then I would show how to actually build the whole. Then we would finish the Perl script that I started here that will interact with this Postgres database. So you will see that you have one Perl script running in one container, and then talking to a Postgres database in another container. One more thing maybe I should mention is that up till now, well, actually, there are a couple of more things I just remembered because, yeah, let me show the first one. So the first one I wanted to show you is that here in this example, what you can see is that we are mapping the external disk to the internal disk, the external disk on my own computer, the host computer, to some internal folder inside the container. So by default, what you saw up till now is that there's total separation between the disk that the container runs on and the disk on my own host computer. And this is the normal way to use the Docker containers for production. But especially during development, you might want to map your a folder on your external computer, on your host computer, to a folder inside. And you can do this in the run command by saying, this is just running pwd on my host computer, so mapping the current folder onto the /opt inside the container. And this is very good because then I can run my editor on my host computer, and while I have access to all of the code inside the container. So I don't have to copy it all the time. It's during development, it's very useful that I'm editing on my computer where I can have all kind of IDEs or Vim or whatever, or Emacs or whatever you like, while running the same code inside the Docker. And then you don't have to install Perl on your computer or the specific version of Perl. You can, and you don't need to install all the modules. You can have everything inside the Docker container. And obviously it's good because then you can pass it on to someone else, the image, and then they can use the same thing without wondering how to install the specific version of Perl and the specific libraries and so on. So that's what we call volumes. The same thing actually we had in the Docker compose file, and I wanted to mention this. So this command creates a virtual volume of Docker called Postgres database data. It's virtual. I call it virtual because I don't really care where it is located. Docker manages it. So it's basically a file somewhere on my operating system. And then this command maps this external disk basically to the internal /var/lib/postgres SQL data. Why is it important to do this? Because this way I can start and shut down the container. I can even remove the containers that were created by this database. And the database, the data, lives on in this volume. So, of course, you can also delete that one if you really want. But this way, we can have, we can even upgrade stuff, okay? We can have maybe instead of using the latest, we are using a very specific subversion of Postgres, and we would like to upgrade it to another subversion, another version of Postgres that's binary compatible. So the database is binary, so we don't need to dumping anything. And we have the data on our host system somewhere, which is called Postgres database data. So these are the volumes, and I can actually Docker volume ls. I think these are the volumes I have. Okay, so I didn't clean it. This one, the PyDigger, is one of my projects. Okay, and this is the that volume that was created by the Docker compose thingy. Right. Okay. more than an hour. I think it's enough for the presentation. Do you have any questions before we stop the video? No question? Okay.
Can you execute database code when you start the container?
Yeah, you can do. I mean, what you do is you make like a script or something that does that, and when it would be part of like the entry point for the container. So yeah, you could anything you can script would be just the entry point for the container, right?
So the question I think is, do you mean to run the database code on the client or on the database server?
So on the database server to actually, you start the server and then create your DB schema with a script and maybe insert the first user.
Yeah, I'm not sure about that. Probably you can do that. I mean, okay. After all, what you can create a new image based on that PostgreSQL image, and then you can have anything there. Okay.
Yeah, the Docker file you can put you can put commands in there all you want. So yeah, you could do that.
I'm trying to find the example with the entry point.
I mean that run. I mean, you see the run thing you're doing where you're running APK blah blah or apt-get whatever. Yeah, you could run the things for inserting inserting stuff in the database using the command line for your database.
But not when you build the image. That would be bad when you do Docker Compose up.
Oh yeah, well then that would be the entry point script. There's is it like CM? One of the is either CMD or yeah. There's a Docker file directive for that. Yes. So the answer is yes. You can have a thing that every time it spins up, it runs. Yeah, entry point versus CMD. So there are two different things to do. One, yeah, okay, yeah. Gabor's got it.
No, go ahead. Go ahead.
No, I'm not going to like explain the difference between them, but the point is it's possible.
Yeah. The thing that I have to emphasize is that basically there are all kind of commands you can put here. Everything runs during the build except the entry point and the CMD. Okay, so all these run commands, they are getx and the copy and all kind of couple of other things that there are there, they are executed while Docker the image is being built. And then you can have this entry point and CMD, which are basically just two ways to slightly different two slightly different ways to tell Docker what to execute when you run Docker run, when you execute Docker run. So this is the default, and then basically you can put here I have curl, but you could put also a bash shell script. And then that shell script can do whatever you like. And maybe the last command of the shell script is to start the database server. Okay, but before that, it can do all kind of things. Now, because this, I'm not really sure how we would, because the database server is not running yet. But I guess you can run commands without the database server, but telling to do it inside the database, right?
Yeah, you'd probably
part
of that part of that runs part of your run statements and all would probably set up like a system service or something like that, so that when it boots up so the database server runs as a service, so it'll be running when the container spins up as a service, and then as a daemon. And then at that point, your entry point or whatever would populate it. That's how I would do it.
Okay, so I don't know if that's how. Yeah, that's
it's confusing. Unfortunately, it's confusing.
Yeah.
And
okay,
that will recreate the database every time you run. and if you mount it, it won't do anything. So you won't delay.
I mean,
Interesting.
there's so many ways to get this done. You could maybe make it so that you save the database stuff as a separate persistent volume, and it just mounts it every time, and that way the volume's already there. Even when the container, even when you shut down the container, the data is still there in the volume, so that when it spins back up again, you don't have to recreate it. It's just there already. There's so many. God, it's so.
Yeah.
There's so many pieces, but yeah, yes, you can do it. You can make it so that it creates the database if it's not there already, and then it persists after you shut down the container. I mean, that's what, at least I'm saying this like I know what I'm talking about, because but I recall that's how my previous employer used to do it.
Okay, so other people are asking the same question, okay, about MySQL, but probably the same idea. Okay, so I don't have an exact an answer for this ready, but yeah, these are the possibilities. Any more questions still in the video?
I may have a question with which I don't really know if it belongs here. It's a bit of specific. A colleague asked me to ask what the policy is about security fixes in the Perl image, and and if the fixes in the Debian base image are taken into account.
If I recall correctly, it just bases itself on the Debian image. So whatever Debian publishes to Docker Hub gets consumed by the Perl image.
But it wouldn't
Right.
happen until the next time the Perl image was regenerated.
That's true. That's true.
Yeah. And then
So,
yourself.
So, you could, if, so you either pull down the Perl image, or, if you're terrifically concerned, you pull down the Docker file for it, and then BYOB.
Yeah, I'm trying to figure out if I can get access to, if I
I
can
don't know.
find the Docker file for this one.
It's you'd have to dig.
Yeah, it's here, I guess. Docker Perl.
Perfect. Thank you very much.
So I guess this
Yeah,
is
but
how this is how it's being built, and when and how. That's okay. So that's I don't know.
Also, typically your Docker files will be pinned to particular versions of their dependencies on other images. So, that way you don't, it's that way it's not, you don't spin the wheel and say, oh, which one am I getting today? So they're usually pinned to a particular version of Debian or whatever.
Your own from the from field, right?
Yes, exactly. From.
Yeah. So it's the usual trade-off that you pin it to an exact version, and then you are stuck with that, or you go with some from floating flag, which is like if you say you want 540, then it will get the per 540. It will get you the latest version of 540. Okay, as the last digit changes. But if you say 540.0, then you will get 540.0 all the time. And if you say per 5, then you will get the latest when 42 comes out, then that will be the one, right? Whatever version. So that's the usual trade-off of deciding which version you want to use.
Yeah, usually the done thing is you pick like the major and minor version, and you let the the patch level float. That way you get every time you build, you get the latest until you go into production, then you pin everything.
Yeah. Okay.
Thank you.
Okay. So I think I stopped the video, and thank you for attending the meeting. The meeting will continue after the video. We are just not recording it. Thank you for everyone who was watching the video, those who are on YouTube. Please thumb up and follow the channel. And also, I would like to mention that on the meetup page, you can find the link to all the people, the places, and the people who were supporting me basically financially. So that allows me to have these meetings, and I would be happy to have more people so I can do more of these meetings. And also, I would be happy to get suggestions or ideas or requests of what kind of topics to try to cover in these presentations / meetings. So thank you, and bye-bye.